A 10 kg block is on 25-degree inclined plane. The coefficient of sliding friction between the block and the plane is 0.45. First, we're going to calculate the velocity, and B, distance of the block after 2 seconds if it slides down in the incline from the rest. So the first thing that we're going to do here is to draw the free body diagram out of it. So this one is 25 kilograms. And then we're going to have here our 25 degrees. And then take note that we're going to have the weight, which is mg. And the weight, that would be 10 kilograms multiplied to 9.8 meters per second square. And the weight, that would be equal to 98 newtons. Next, let's try to identify all the other forces here. So the forces here, we're going to have the force parallel, or that would be the weight parallel. That would be the forces coming from the weight, which is equal to sine theta mg. And then another one here, we're going to have the frictional force. And then likewise, we're going to have the normal force. And then we're going to have the force perpendicular, or weight perpendicular. And so here, we all know that the weight perpendicular, that would be cosine theta mg. Now, this might be quite different from the previous problem for the static friction, simply because the box is moving down. And so we could expect that it is accelerating. And so our concern here is to first get what would be the acceleration of this block coming from the inclined plane. And so first, we're going to have the summation of x and summation of y. So this would be my y-axis, and this would be my x-axis. Now, the summation of forces in the y direction, that would be the normal force minus the weight perpendicular. And the normal force here, since this box is not moving in the y-axis, it could be up and down from the y-axis, and therefore we could say that the summation of Fy would be equal to 0. And 0, that would be the normal force minus the weight perpendicular. And if we're going to try to solve for it, that would be the weight perpendicular, that is equals to Fm. And what is again the weight perpendicular? That would be the cosine theta mg. And we're going to press now the value of cosine of theta mg, which is a direct substitution of cosine of 25 degrees multiplied to 10 kilograms multiplied to 9.8 meters per second square. And therefore the normal force, if we're going to press it in the calculator, that would be 88.82 newtons. Next, if we'll try to look what will be the summation of Fx. The summation of Fx would be the weight parallel minus the friction. And since that would be moving, going down, that is not equal to 0, but rather the summation of Fx would be equal to mass multiplied to the acceleration in the x direction. And so, we're going to have max is equals to weight parallel, that is sine theta mg minus the friction. And if we'll try to observe here, the max is equals to sine of 25 degrees multiplied to mass, which is 25, which is 10 kilogram, multiplied to 9.8 meter per second square minus the friction. But there's a problem here. We don't have yet the friction. This will be our main concern. But we all know that the value of friction would be the mu kinetic times the normal force. And so the frictional force would be the mu kinetic, that is 0.45 from the given, multiplied to the normal force, which is 88.82. And then the frictional force, that would be 39.97 Newton. And so we can simply continue now how to solve for the problem. We're gonna have here the mass would be 10 kilograms multiplied to AX. That would be sine of 25 degrees multiplied to 10 kilograms times 9.8 meter per second square minus the friction, which is 39.97 newtons. And solving for that, that would be 10 kilograms multiplied to the acceleration, and that would be 1.45 newtons. And solving now for the AX, that would be 1.45 newtons divided by 10 kilograms. And so the acceleration would be 0.14 meters per second square. Well, why it becomes 0.14? Now, if you're just wondering, this one is actually, this value is actually 1.446. Let me double check. Okay, this one is 1.446. And so that would be best rounded off as 0.14 meters per second square. Okay? Now, that would be our acceleration, which will be used in our three kinematic equations. Now, if we will try to solve for our three kinematic equation, we're looking for the distance of the block after 2 seconds. Now, let's try to use the three kinematic equations here. So the distance of the block after 2 seconds, the best equation for here, remember we have three kinematic equation. We have d is equals to VIT plus AT squared over 2. We also have the VF is equals to VI plus AT. And then we also have the D is equals to VF squared minus VI squared all over 2A. Now, for the first question, if we try to look here, what will be the distance? Calculate the velocity. Okay, so if we're gonna calculate the velocity, the best equation here would be this equation 1, which is a VF, that would be VI plus AT. Since it starts from rest, the VI is 0, and then VF would be the acceleration multiplied to time, and that would be 0.14 meters per second square multiplied to the time, which is 2 seconds. Then the VF here would be 0.28 meters per second. Okay, next. Now, how about after, what would be the distance after 2 seconds? So the best equation that we can use here would be D is equals to VIT plus AT squared over 2. Since VI is 0, we're gonna cancel this out, and we're gonna be left out with AT squared over 2. So plugging in, the acceleration is 0.14 meters per second square multiplied to the time square, which is 2 seconds square divided by 2, and that would be equal again to 0.28 meters. And that's it. We already solved for the final velocity and for the distance when this 25 kilogram box would gonna go down the inclined plane for around 2 seconds. And thank you for that, and kindly answer your problem sets in our worksheet.